Assalamualaikum and good day. Now I will explain the coding for my FYP titled Classification of ADHD using Deep Belief Network. This coding use a Python module that is Nelearn. So firstly is to install the Nelearn, then to also import some of the related libraries that will be used. Next is to load the data from the Nelearn. The study will use 40 subjects of the data. So firstly is to fetch data. Next we can see the keys provided in the module. That is function, confound, phenotype and description. We can clarify the length of the data is 40. Next is to get the functional files, so they can be used later. Next is to do independent component analysis for group level. So retrieving the component using masker to project into the 3D space. Plotting the default mode network. So from this picture we can see the DBN before and after region extraction. Next is to use a filter to extract the region time series. Then computing the region signals and extracting the phenotypic information of interest that include the subjects and where and the sites the subject are from, as well as the label. Next is compare the three types of functional connectivity between region of interest. Next is to classify using connectivity coefficient and linear support vector. Then is to visualize the result and the accuracy. Then next is to display the connector for more accurate kind of functional connectivity. Next is to display the connector, but first we need to do connectivity matrix for each subject, separating the correlation matrices between treatment and control subject, and then getting the mean correlation matrix for all treatment subject and control subject for those with ADHD and non-ADHD. Next is to visualize the mean correlation. The first picture shows the correlation between 20 regions for those with ADHD, and the second picture is the correlation between 20 regions for those with non-ADHD control. Next is to plot the connector. First picture shows the correlation between 20 regions for ADHD and the correlation between 20 regions for those control. It can be seen there is more connector in head ADHD than the connector in the first picture than the second picture. Next, we can visualize the connector. Next is to visualize the connector into 3D. Before applying the data into model, first is to split data. 20% of the data is used for testing and the remaining 80% for training. So 0.2 test size. Next is the DBN model itself, containing the weight and hidden layers. Firstly is to train the DBN using RBM. First is to set the hidden layers. For this study will use 3 hidden layers with 256 units for each layer. The learning rate, length for RBM and length for DBN. The batch size, activation function is set to value, and drop out. All of the parameter is set before applying the data into the DBN model. First is to test the data and get the accuracy. To better understand the result, we can output the conversion matrix and classification report for more detail. We can also visualize the confusion matrix as can be seen here. And that's how the coding works. Thank you.